I want to try and find a quick but accurate way of getting speeds of vehicles. Pixel tracking is a technique where you track a pattern of pixels across an image. So the software allows you to define a window, which chooses your pattern. It could be something like a taillight, a logo, a license plate that the software can just lock onto. Once it gets that pattern, it tries to find that same pattern in the consequent frames, and as it does, it tracks that feature throughout the sequence. I can use this tracking software to just track like headlights and license plates or emblems on vehicles, and since I already know the camera motion from having tracked it before, I can use that information along with some information about the vehicles to determine the location of that tracking point in 3D space over time, which would give me speed. When you have the camera and you have the pixel tracking, it gives you this vector just going out forever in space. You have to have some way of stopping it to like figure out where exactly it is. You know it's along that line, but figuring out where it is on that line, you need one other piece of information. So the thing we write about in this paper and the thing I did in that particular example was look for the height off the ground. See if the headlight is supposed to be 2 feet off the ground, I find the point where it's 2 feet off the ground, stop it, solve that point, and that's where that point is in 3D space at the time. You have multiple frames, you got your speeds. We actually had a train derailment we did up in Montana. We wanted to recreate it, so William actually went out there and derailed the train, just like happened in the accident. And basically what we did is, we set up 2 high-speed cameras so I could triangulate points. So we had those set up and I tracked points all about the train. I think it was like 12 of them in both cameras using the same technique. And I got 3D points for all of those. Then using those 3D points, I was able to see how they all move together and solve for like a single transform from it, which gave me position and rotation. And from that, I was able to like recreate the exact motion of the train. You can see the actual footage and you can see the reconstructed footage that I did using that technique, and they're nearly identical. Mainly the software used for tracking is PFTrack. That's what we use for tracking the video and the 2D tracking as well. I have also used After Effects for that. This particular software we also use does also have the ability to load in LiDAR data, and you can take your tracking points and you can assign it a point in that LiDAR data. You can tell it this point is actually this scan point, and you can do it for multiple points. There's nothing in existence that actually takes that 2D data and transforms it into like a 3D coordinate like we do here. That was all custom written stuff, so that's all scripts we've developed.